So in this question, we are going to solve what? Finding the performance parameters of three-phase full converter drive with field control also is included. Previous case it was not included. Okay. So the same I think values also might be the similar only, but we'll see. The speed of the 20 HP, 300 volts, 900 RPM. So it has been changed now. So 20 HP, 300 volts is the rated values. Separately excited DC motor again is being controlled by three-phase full converter drive. So we'll be using two formulas. One is for the two set of formulas. One is for the three-phase full converter drive. Two formulas will be there, VA and VF. And separately excited DC motor, I hope you know the formulas, all the formulas you have to remember: VA, EG, TD, develop torque, everything. Okay. The AC input is a three-phase star connected, 208, 208 volts, 6 volt supply. Okay, that is fine. So let us start writing the values given. AC input, so I'll just mark it over here, 208 volts. So whatever is given AC input, that will be line voltage. So whatever they'll be giving, you have to consider it as what? Line voltage, 208 volts. But we have to take what the phase voltage is. So in star connector, remember that in delta it is the same, phase and line is same, but star it will be, phase will be VL by root 3. So 208 by root 3, you will be getting the answer as what? 160, sorry, 120 volts. Next. Armature resistance is given RA, RF is given, motor constant again the same thing. So RA is given as 0.25 ohm, RF again 145 ohms, kV the motor voltage constant 1.2, volt per ampere, radian per second. Okay, unit of that. Next important thing, the armature field and current can be assumed continuous. Okay, that is fine. Mixture friction. Okay, that is also fine. A part they have started. A part we have to find if the field converter is operated at maximum field current. Okay, and the developed torque at 900 RPM, which is the rated value itself. Determine the delay angle of armature converter alpha. See, there are two delay angles. One is for the field converter, another is for the armature converter. Armature converter it is alpha A, field converter it is alpha F. In order to find out alpha A, so we need to find out what alpha A, TD is given at 900 RPM. Let us see. A part of the question will start. We have to find out alpha A. In order to find out alpha A, always remember we have to go for, as I said, three-phase full converter. We are having two formulas, V and VF. VA is related to IA, VA is related to alpha I, VF is related to alpha I, delay angle. Okay, so VA is equal to 3 root 3 Vm by pi into cos alpha A. Here I need to find out alpha I. So I have to shift everything that side. So it will be VA into pi divided by 3 root 3 Vm into, if I take cos inverse, then I will be getting alpha. Simple. I have just shifted everything, that's it. Okay. Now here what all values is given, that is the important thing, right? Pi anyways constant, 3 root 3 constant, Vm and Va, the two important things. Vm is basically V phase we calculated, right? Whatever the V phase is there, that you treat it as Vs, as we have done in previous problem, single phase, right? So that you have to multiply it with what? Root 2 in order to get Vm, peak voltage. So V phase into root 2, 120 into root 2. It is 169.7 volts. VA, simple formula of VA, which is nothing but IARA plus EG. Now here, which is the given thing? RA is given, you can directly see. IA is not given. Okay. EG also not given. So these two things not given. So how will you find IA? IA you can go with the torque equation. But in the previous case, you remember previous problem, IA we were not able to find out using torque equation because their TD was not given. Torque developed was not given. But here TD is given. So simple thing. So TD is equal to, it is KT IF into IA. From this I can see KT is same as KV. Okay. Torque constant and voltage constant is same. So IA becomes here TD divided by KV into IA. Now in this IA have to find out. TD is given. It is given, it is said that you have to consider TD as 116. Newton meter. kV is also given 1.2. What about IF? IF we have to calculate using which formula? VF by R. So again I'll come to IF, which is you have to calculate by VF by R. Now RF is given, that we know, 145. What about VF? VF is not given. How to find out VF? Again the converter formula. VA formula we had. So VF also we are having the same formula. Only difference is that 3 root 3 Vm by pi, instead of cos alpha A, it is alpha F. Now alpha F is not given in the question, right? So how will you find that? Alpha F, always remember, whenever you are calculating VF, you have to consider alpha F as 0. So alpha F is 0 because in order to get the maximum voltage and current. Okay, for the maximum voltage and current for the field, we are considering alpha F is equal to 0. So cos 0 becomes 1. So the final formula of VF becomes just the 3 root 3 Vm by pi. Okay. So 3 root 3, what is Vm? We just calculated, it is 169.7 divided by pi. So VF you will be getting it as 280.7 volts. Now I can just put directly here VF. So it will be 280.7. In order to just divide this, we'll be getting 1.936 amperes. After getting IF, I can again substitute here. So it will be 1.936. So then I can get the value of IA. So IA becomes this particular thing you have to calculate, right? So IA becomes directly TD divided by kV into IF, which is equal to 49.93 amperes. I hope you understood what I have done. After getting IA, so this part we have got. So this part we have got. Now I need to get what? EG. Now how to get EG? We are having the motor formula, which is that EG is equal to kV into omega into IF. Now in this, what is the given value? IF we just found out, okay. kV is also given. Omega is whether it is given? Yes, it is given. They have said that 900 RPM. What is they have said? The A part, if you understand here, they have said delay angle of the converter. So developed torque is at what? 900 RPM. Okay. But as we have said that, as we have understood that omega you cannot take directly in RPM. We have to convert into radian per second. So whatever is the kV value is 1.2 into omega I am going to convert. So 900 RPM is there. We have to convert into radian per second, just to multiply by pi by 30. We have discussed many times this thing. Still I'll tell you here. RPM to radian per second is just to multiply radian per second is just to multiply RPM with 30 by pi. If you want to convert radian per second into RPM, you have to just multiply radian per second with 30 by pi. Simple. EG is equal to, you're getting 94.25 radian per second you will be getting. Okay. Now you substitute. What is kV value? 1.2. What is omega? We just found out 94.25. What is IF value? IF is the field current, which is 1.936. It is over here sitting. Okay, we found out that also. So EG value you got. How much you are getting? EG value as 218.96 volts. This EG value you have to substitute over here in order to get VA. Okay, so we are back into that formula. So VA is equal to IARA plus EG. So what is IA? 49.93 into RA, armature resistance given in the question is 0.25 plus EG just now found out. You will be getting VA value as 231.44 volts. After getting VA value, I need to find out delay angle alpha I. So that formula is given over here. So alpha is equal to cos inverse of alpha A is equal to cos inverse of VA into pi divided by 3 root 3 into Vm. So that is equal to cos inverse of VA value found out 231.44 into pi divided by 3 root 3 into Vm. Vm we found out here This is the Vm value 169.7. So alpha A becomes cos inverse of that. You will be getting in degree. It is 34.46 degrees. You will be getting the answer in degrees. Okay. So I think I'll give you a short description of what we have done in first question. So first question, basically, if you want, you skip this. Go for the B part. Okay, B part you have to find out. So A part, what they have asked, they have asked us to find out the delay angle, determine the armature converter delay angle, which is alpha A. I'll give you the short description over here. Okay. In order to find out the alpha A, always remember we are going for the formula of VA, which is nothing but 3 root 3 Vm by pi into cos alpha A. This formula only we are going to find out alpha A. But here the problem was that VA was not given. Vm anyways, what we did, how we found out VA? Given question, VL will be given. We are finding V phase by just dividing VL by root 2. Then V phase we are multiplying with root 2 in order to get what? VM. Simple concept. Okay. Now VA, how will you get? VA, the separately excited DC motor formulas we are having IA, RA plus EG. In this, only RA we know. EG and IA we don't know. We have to find that. IA to be calculated first. Then EG. So IA, how will you find out? By the torque equation. Develop torque equation, I can find out IA. Because torque equation is given by KV or KT, the same thing, both are same, into IF into IA. From this I can find out IA value by just taking torque divided by kV into IF. But again here again same problem. TD is given, okay, kV is also motor constant given. IF I don't know. IF again I have to go for the formula VF by R. RF I know, but VF I don't know. So VF, in order to find out, the formula will be what? 3 root 3 Vm by pi cos alpha f, where alpha f we have to consider 0, so cos 0 is 1, so you have to calculate. So Vm we know, we will get what? Vf. Vf you substituted, Rf you substituted, you got what? Ia you are going to substitute here. Then Eg we have to find out. Eg, how will you find? Eg is basically by using this formula, kV into omega into IF. Remember, omega always should be in radian per second while substituting in EG formula. So that's how we are going to find out. IF anyways we know. EG we found out. At last we substituted in VA formula. This formula will be getting the answer. So A part was quite lengthy. Let us go for the B part. Okay, B part actually starts from here. Okay. Okay. So B part says if the field circuit converter is set for maximum field current, okay, that is fine. Torque developed is again TD same. Delay angle of the armature converter is, I missed here. The armature here in B part you have to consider alpha A is equal to 0. It is given in the question. Okay, here this part I missed. Determine the speed of the motor. So speed we have to find out. When alpha A is equal to 0, we have to find out, and torque is given. Okay, fine. Let us go for the B part of the question. Remember that what is given, they have said that alpha A should be equal to 0. The armature delay angle they have said 0, and TD anyways they have mentioned it as 116 Newton meter, and they have asked us to find out the speed of the motor, omega. This you have to find out. How will you find out omega? What is the formula we are having? See, we have seen the formula of EG, which relates to omega. EG is equal to kV into IF into, or kV into omega into IF. Here omega is sitting. This omega becomes what? Eg divided by kV into IF. Correct? I need to find out Eg and I need to find out IF. IF kV is anyways fixed. Now what about IF? IF will be anyways VF by RF, which we found out earlier. It will remain same. IF we know, we found out here itself. This particular value 1.936. So IF I am not going to change, 1.936. What about EG? EG is going to change. Why it will change? Because alpha A you have to consider it as 0. So whether EG is related to alpha A, it is not directly related. But in order to find out EG, we use the formula VA is equal to IA RA plus EG. From this, Eg becomes Va minus IARA, correct? Where RA we know it is 0.25 given in the question. IA we calculated, you remember, it is IA is 49.93. That is also fixed. What about VA? VA is directly related to alpha A. So for that reason they said alpha A should be taken as 0. Now in order to find out VA for 3-phase full converter, the formula 3 root 3 by Vm by pi cos alpha A. This alpha A you're going to take it as 0. So that means cos 0 is 1. So it will be 3 root 3 by pi into Vm. So what is the formula? What is the answer for that? It will be, it is same as VF. See, VF we calculated it is alpha F is equal to 0. Here they have said alpha A is equal to 0. If you observe here, where is VF? Ah, here, this part you see, alpha VFI just wrote same 3 root 3 Vm by pi. But here cos alpha F was there, as I said. Alpha F I consider 0. Here same case, alpha A is equal to 0. It will be the same answer as this thing. So it will be, again, Vm you have to substitute 3 root 3 by pi. So you'll be getting V answer as 280.7. Same thing as what VF we calculated in the first case. Okay. So now VA you got. I need to find out EG. The same formula you substitute. So EG is equal to VA is 280.7 minus IA 49.73 into RA is 0.25. So you will be getting EG value as how much? Subtract this thing, you will be getting it 268.22 volts. Okay. Now you substitute back in this formula. So omega becomes Eg divided by kV into IF. So Eg value is 268.22 divided by kV is 1.2 into the IF value is 1.936. You will be getting the omega value speed of the motor as 115.45 radian per second. You will be getting in radian per second only, remember, not in RPM. In order to convert this into RPM, as we have discussed before also, we have to just multiply this by 30 by pi, not pi by 30, 30 by pi. So omega becomes, if you multiply 30 by pi, 1102.5 RPM. This is the speed of the motor in RPM. This is the second part, B part of the question. Now let us go for the last part of the question. So they are saying, last part of the question, let us see. For the same load demand in B, determine the delay angle of the field converter if the speed has to be increased to 1800 RPM. So earlier the speed was 900 RPM. If you observed in the second part and first part of the question, 900 RPM they have said. Now you are going to increase the speed of the motor. You have to calculate the delay angle of the field converter, alpha F. You have to calculate. C part of the question, you need to calculate alpha F, field converter delay angle. How to find out? VF formula you have to apply. 3 root 3 Bm by pi into cos alpha F. From this you have to calculate alpha F is equal to cos inverse of Bf into pi divided by 3 root 3 into Bm. Find Vf. Vf is nothing but If into Rf. I into R. Like we found out If, no, same formula. So what is If then? If, will If be same? That is the question. If we have considered 1.936. Here also If we have considered what? For solving the B part, If is 1.936. Whether it will remain same or not here. No, it will not remain same. See what is given in the question. They have said that speed also has been increased to 1800 RPM. Now what is the relation then? If can we relate to omega? Yes, you can relate. How we are going to relate? By using the Eg formula. See, Eg we have studied that it is equal to kV omega into If. From this I am going to find out the new If, which will be Eg divided by kV into omega. Now Eg will be remaining same. Whatever we calculated in the second part of the question Eg, that only we have to take, because in the question they have said Eg whatever is the same below, so low demand as what, B part. So same thing we have to consider as B part. So here we are having the Eg answer as what, 268.22 in the B part we got. kV is how much? 1.2, it will be fixed. Omega is 1800 rpm. You have to convert into radian per second, just to multiply by pi by 30. Okay, so we will be getting the answer as in radian per second, 188.5 radian per second. This you put it over here, 188.5. So we will be getting the IF value as how much? 1.186 amperes. This new IF value you substitute here in order to get VF. So 1.186 into RF. Field resistance is given in the question, as you can see over here, 145 ohm we have taken. 145 ohms we have taken. So we will be getting the VF answer as 171.97 volts. Then you have to substitute in this formula to get alpha F. So alpha F becomes how much? Cos inverse of VF. What is VF? 171.97 into pi divided by 3 root 3 into Vm, which is 169.7. You will be getting alpha F in degrees, which is equal to 52.2 degrees. So alpha F also you got. This is the C part. So you have to be careful while doing the question, because the new speed has arrived. You cannot take IF as the same value. In the B part also, you have to understand here, I cannot take the Eg as the same value, because alpha A they have given as 0. So one part of the question, they are something they have added. They are giving some new values. So based on that, you have to change the values also. Okay, so you have to read the question carefully.